Hi everyone, this is Mrs. J, and today we're going to be adding and subtracting rational expressions. I have a quick warm-up for you guys, so if you could pause the video and give it a try, you can hit play whenever you're ready to check your answers. Alright, so go ahead and check your work here. So remember, to find a least common multiple of values like 18, 9, and 48, it might help to look at the prime factors. So you have to make sure that when you're finding that least common multiple that you have factors that accommodate all of the possible factors of your three original expressions. So you could see that they all share a common factor of 3. But the first two share another factor of 3, so you need to include that. And then our last factor has 4 powers of 2, so you have to include all of them, which would accommodate also the power of 2 from 18x. And then we have to essentially pick the highest degree of x to make sure we can accommodate that in the least common multiple, so it'd be x cubed. So 144x cubed is the least common multiple of these 3 terms. So that's another way of saying this is the smallest number that all 3 of these terms can divide into evenly. Now, when you have expressions like this, we can kind of do the same thing. We can find the factors. So our factors, the first one are x and x minus 5, and then x plus 5x minus 5, x minus 5, and x plus 4. So they all have x minus 5, so we need to include that in our least common multiple. But I also see a factor of x, which I'll include, a factor of x plus 5, which I'll include, and a factor of x plus 4. So you have to make sure all of the possible factors from any of these 3 original expressions are included in your least common multiple. So today we're going to be adding and subtracting rational expressions. So we know the rule for adding fractions is that the denominator needs to be the same before we add or subtract. So today we're going to be finding the least common denominator of our rational expressions, which involves finding the least common multiple of our denominator, which is why we did that in the warm-up. And then we need to make sure we create that common denominator by multiplying the numerator and denominator, maybe of one expression or maybe multiple expressions. And then once the denominators are the same, we can just add the numerators, and then we're going to simplify if possible. So we're going to combine like terms and see if we can simplify. And then we're also going to identify any excluded values, so essentially restrictions from our denominator, where our denominator would equal 0. Because remember, your denominator can never equal 0. All right, so let's give this first one a try. Here we have 2 expressions. So I need to find the least common denominator first. So I'm going to factor everything as much as I can. So we have x squared is already factored. And then our other denominator, we can say x times x plus 1. So for our least common denominator, we need to make sure we include all of the parts from both of our denominators. So here I have x, but here I have x squared, so I need to include x squared in our denominator, and I also have the factor x plus 1, so I need to make sure that it's included. So our least common denominator is x squared times x plus 1. So now I'm going to look at each expression and say, okay, what's missing from my denominator? My first one, I have x squared, but I'm missing x plus 1, so I'm going to multiply the numerator and the denominator by x plus 1. And then for my second expression, I have x plus 1. I have 1 power of x. I need it to say x squared, so we're going to multiply the numerator and denominator by x. Okay, so now you can see we have 2 expressions that have a common denominator, which means that I can just simply add the numerators to create a single expression. So we have x plus 1 times x squared plus 4x plus 2 plus x cubed, x squared times x, all over our LCD of x squared times x plus 1. And then from here, it's just a matter of multiplying out our numerator to combine like terms and to possibly simplify. So we have x cubed plus 4x squared plus 2x plus x squared plus 4x plus 2 plus x cubed all over our LCD. So that gives us 2x cubed plus 5x squared plus 6x plus 2 all over x squared over x plus 1. And then from here you would see if there's any way you can factor and maybe simplify. In this case we can't, so that means that we are done. So here's our simplified expression. However, we also need to include our excluded values. So what can x not be? So to do that, you simply look at your denominator and you essentially set any factor in your denominator equal to 0, and that will be an exclusion, right? Because the only time we have excluded values with fractions is when our denominator is 0. So from this factor of x squared, we can see that x cannot equal 0. And from this factor of x plus 1, we see that x cannot equal negative 1. So we have two excluded values for this expression. Okay, let's have a look at the second example together. So I do need to create that common denominator before we add. So I'm going to factor. So first I notice that there is a GCF of 3. So I'm going to factor this out on the side. Well, I'll factor here. And then we have x squared minus 2x minus 8. And then this we can factor more. And something that you might notice, we have a common factor of 3. Since it's just a value, we can actually just simplify it out. Now, if it were a variable or a factor that's going to cancel out, you can simplify it, but we need to make sure that we make a note of any excluded value before we do that. But in this case, it's simply a value, so we can simplify this out. 3 over 3 is 1. And I'm going to finish factoring my denominator here, x minus 4 times x plus 2. Okay, so now I need to figure out what my LCD is. So the only factor in my first denominator is 5, and then we have 2 in my second denominator. So our LCD is 5 times x minus 4 times x plus 2. So I'm going to see what's missing. So from our first expression, we're missing x minus 4 and x plus 2. So I'm going to multiply that in the numerator and denominator. And in our second expression, we're missing the factor of 5, so I'll multiply by 5. So now we're ready to add our expressions. Plus 5x all over our LCD. I'll just do that to save us a little time. Now we just need to multiply out our numerator. So that gives us 2x times x squared minus 2x minus 8 plus 5x over our LCD. And then we have 2x cubed minus 4x squared. And then here we'll have negative 16x plus 5x, so negative 11x over 5 times x minus 4 times x plus 2. Now in our numerator, we could factor out a power of x, but we wouldn't be able to factor the expression anymore anyways. So we can leave it like this, or again, we could factor out that power of x. We should check because sometimes you can factor the remaining expression in your numerator, and then sometimes there's a common factor. In this case, there's not. So this is simplified. So this would be our answer. And then we do need to state the restrictions. So from our denominator, I see that x cannot equal positive 4 or negative 2. And that's it for this problem. All right, we're going to try one more together. We're going to subtract these two expressions. So first I'm going to factor when we can. So minus 6 over 2 times x plus 1. So we can actually simplify our expression on the right. I do want to remind you that you cannot simplify the expression on the left. You can only cancel out common factors. So when things are being divided like this, 3 is not a factor of your denominator. It's part of this binomial. So you cannot just cancel out part of your denominator. But on the right, you can see that I have a factor of 2, and the numerator and denominator are divisible by 2. So this we can simplify. So now I can look at this and decide what our least common denominator is. So our least common denominator is going to be 3x minus 5 times x plus 1. So I can see what's missing from each denominator. From the first expression, we're missing the factor of x plus 1. And from the second expression, we're missing 3x minus 5. So that leaves us with 3 times x plus 1 minus 3 times 3x minus 5. Be careful with that minus. And all of that is going to be over our LCD. Now we have that common denominator. And then here we're just going to multiply it out and combine like terms. So here we have positive 3x minus 9x, so we have negative 6x. And then here we have positive 3 plus 15, so plus 18 over our LCD. And then since we can, let's just factor in our numerator to make sure there's no way to simplify. So we'll factor out negative 6 times x plus 3, x minus 3 over our LCD, which is 3x minus 5 times x plus 1. So there's no more common factors, so this is our simplified answer. And we can see from the denominator, again, that x cannot equal positive 5 over 3 or negative 1. Okay, so at this point I'm going to ask you to pause the video and give this one a try on your own. And when you are ready, you can check your answers. All right, go ahead and check your work here. So when you factor your denominator on the left, you get 2 plus x times 2 minus x. So 2 plus x we can just rewrite as x plus 2, or you can leave it. But here we have 2 minus x as one factor, and here we have x minus 2 on the other side. So actually, if you take the 2 minus x, and if you factor out negative 1, we're left with x minus 2, creating that common factor of x minus 2. So our least common denominator is negative x minus 2 times x plus 2. So you can see I made that common denominator, and then I combined the numerators and multiplied it out to get x squared plus x plus 2 over our least common denominator, and then x cannot equal positive 2 or negative 2. Okay, here's one more for you to try, so please pause the video and you can hit play when you're ready to check. All right, go ahead and check your work here. So on the left, you can simplify this to just 2x, and then on the right, you can factor your denominator. This is your LCD, so you just multiply your LCD to the numerator denominator of the expression on the left, which is your original denominator. So here you just need to distribute the 2x and combine like terms, and then you have your simplified expression, and x cannot equal negative 6 over 5 or positive 4. All right, so now we're going to see if we can create some models where we need to add and subtract rational expressions. So this first example says 2 student clubs have agreed that they will each contribute $2,000 for an upcoming event. Group A has 6 more people than Group B. If X represents the number of people in Group A, create an expression that models the difference between the number of dollars each person in each group must contribute. So we want the difference between how much each person in Group A contributes and how much in Group B. So we have a Group A and Group B. And again, they ask for the difference between how much each person in each group is contributing. And we are going to assume that every person in Group A is going to contribute the same amount and every person in Group B is going to contribute the same amount. So if Group A is going to contribute $2,000, and that's split up evenly over X people, because it says here that X represents the number of people in Group A, we can describe how much each person will pay by saying 2,000 divided by X. That's how much each person in Group A will pay. And then we're going to do minus, well, Group B has also agreed to contribute $2,000, but that's split up over 6 fewer people, because it says that group A has 6 more people than group B. So group B must be X minus 6. So again, this $2,000 is split up over X minus 6 people. And then we want the difference in these two. So we have 2 rational expressions that we can combine after finding and creating a least common denominator. So here our LCD is X times X minus 6. So we can see that here we're missing the factor X minus 6, and here we're missing the factor X. So this gives us 2,000 times X minus 6 minus 2,000X over our LCD. And then here we just multiply it out and combine like terms. So here we have 2,000X, and then we have minus 2,000X. So those will cancel out. And then we have minus or negative 12,000 over our LCD of X times X minus 6. So this represents the difference in how much each person will pay from group A to group B. And of course here we do have 2 restrictions. X cannot equal 0 or positive 6. Okay, let's try one more together. So this one says a freight train averages 30 miles per hour traveling to its destination with full cars, and it averages 40 miles per hour on the return trip when it has empty cars. Create an expression that models the total time that the train is traveling in terms of d, which is the distance that it travels in miles. So for this, we can think back to a really basic equation. Distance equals rate times time. And here we want to model the total time. So we're going to use t equals d over r. So we have the time when they're traveling 30 miles per hour. And again, the distance, we're just keeping it d in terms of d. So the trip there, we can model that with d over 30. So it's the distance over the rate of 30. And then since it's also making a return trip, we'll add the time returning when they were traveling at 40 miles per hour. So d over 40. Now all we need to do is add up those 2 expressions. So in this case, our least common denominator is 120. So we need to multiply our first factor, or our first expression by 4 and our second expression by 3. So we have 4d plus 3d over 120, our LCD, which just leaves us with 7d over 120. So this expression would model the total time that your train travels for any given distance of d. All right, so that is all for today's video. Thank you so much for watching.